Okay, today we're going to talk about Mr. Mercury. In particular, we're talking about the remote control unit, things that can go wrong with it, things that you can, and some things that you can't fix, stuff like that. But maybe we should start first with, in case you're not familiar with Mr. Mercury, there were 3 different versions. I've done quite a few videos out on the hut showing these. Unfortunately, I don't think the word Mr. Mercury is in the title of the video, so unless you just happen to watch all my videos, you may not have seen them. But there was actually a 4th version of Mr. Mercury, but it was sold as Frankenstein. They put a plastic Frankenstein head on it, painted everything black, and put Frankenstein hands on it instead of robot foam pads like this one has. For basic functions, you had a wired remote that took 2 D cells, which I'm loading into the remote now, and we can get this close enough for the camera to see. You can see these 2 top buttons. You have a up down arms, open close arms, then the 2 bottom buttons are walk and bend. Now all the arm functions in the robot are controlled by one motor. When the motor turns in one direction, it swings a gear over, which might make the arms go up and down. When the motor turns in the other direction, it swings a gear over, which then makes the arms open and close. Same thing happens down below. There's one motor that does 2 functions. When you push the walk one, a gear swings in such a way that it engages into the walking mechanism. When you push this one, it turns the motor in the opposite direction, which causes the robot to bow and bend. For example, let's bend. Thought maybe we'd pick that up. So let's try the open and close. That's plenty of open. Try closing on it this way. There we go. And let's bend up. Like that. And then you've got an up and down on the arm. This is going to fall out. Basically just cycles. I'll take it all the way down and then let's open them up. Let's go ahead and close them. And let's try walk. And notice you do have a light when you're in the lower motor positions, this particular one. So this robot was sent to me not for any internal repairs, like maybe getting the arms to go closer together or anything like that. It was sent to have the remote replaced with one that works. So what we're really here to talk about, not so much the robot as the remote, in case you guys ever get one and you have to deal with it. So basically this top button part can come off. Oh, before I even go that far, one of the most common problems, and there were 2 types of this remote, is going to be these broken tabs. You can see this particular one is an earlier version where you have nipples and you have recessed part that tabs on, but the other part is broken off. It almost always would be broken. This particular version, instead of the nipples, they went in with rivets on both ends. This is a little bit more durable. They seem to show up broken a little bit less often. So I'll take that off. Anyway, this top cap can be removed. Let me get a screwdriver and do it the right way. Where you basically shoehorn it. There we go. I'm holding it that way so I don't lose the 4 red buttons, because they're just sitting in a hole in there. So inside here is where you actually have your switches. Now these 2 points here, there's 2 wires that are soldered onto those on the back side, and those go to the motor for the arms. And then there's 2 wires here which go into the black, which go over to the motor for the walk and for the bend. Each one of these switches would be considered a single pole double throw switch. and we're going to get into what that means. Some parts of this you can take apart to clean and adjust, and some parts you can't. For example, if you actually had broken wires where they entered the remote, that's going to be the hardest thing for you to fix, and I'm going to show you why. I'm taking this little nut off here. This is going to remove. I'm trying not to drop the little nut because I'll never see it again. Get this little contact plate. We're going to talk about all these things here, so don't worry about it too much. Now I'm going to rotate these pole pieces out of the way so that you can see this bottom piece of metal. So basically the positive side of the battery touches here, comes down, and in this case I've put a screw in there, but originally when you get the toy from the factory there's a little brass rivet in there. Head of the rivet is on the inside here and would come up and was bent over on the top. But if you have to get under this fiberboard, say to work on wires or reattach them or to clean contacts or whatever, then you're going to have to grind the hammered part of that rivet off and then replace it with a very small, I think this is a 252 machine thread, very small. So basically the power comes in, the positive from in here, touches the head of that screw, so transfers from the screw, then the nut touches this piece of metal when you tighten it all together, and that puts positive on that lower plate. So if you were to push either one or even both of these down with the red buttons, those wires would then become connected with positive. And since they go to one motor, if they're both positive, nothing's going to happen. You've got to have one positive and one negative. Well, that's where this piece of metal that I took off with the nut on the top comes into play. Your negative side of your battery comes up to here, and there is a factory screw in this case. And that little brass-headed screw comes up, comes all the way up through plastic so it's isolated. Then you have this plate that we took off, which is held on there. And then that little teeny nut, which I'm going to put back on before I lose it. Hopefully. If I drop it in trying to put it back on, it's lost. Here we go. Getting there. Like that, and let's snug that down. There we go. So now we have the negative side of the batteries coming to this top plate. We have the positive side of the batteries going to that bottom plate against the fiber board, and you have these spring-loaded contacts. These are the pole pieces of the switches, bent in such a way that they're all touching this top plate right now. So all wires heading back to the robot are actually negative right now. If I pushed either one of these down, since I already told you that this goes to one of the motors, if this one's up and negative and I push this one down and it becomes positive, then that motor is going to run in one direction because you have positive here and negative there. But if I push this one, I then have positive on this side, negative on this side, and the motor turns in the other direction. And that's what's called, each one of these is called a single pole double throw. Single pole meaning it has one pole piece that can move, but it's double throw. It can either be in the up position touching negative, or it can be in the down position touching positive. And pushing them both won't short anything out wired this way, or having them both up won't short anything out. So there's not going to hurt the batteries. So the same thing happens down here. Normally both of these contacts are going to be sitting negative because they're sprung loaded to be up against this plate. And if you pushed one of them down, it's now connected to the positive, while that one's still connected to the negative. The motor runs in one direction, or if you push the other one, then the opposite thing happens. So what tends to happen sometimes is these get corroded, and in this relaxed state, the automatic pushing up part may not make a good connection. And if it doesn't make a good connection, then you can push as much as you want on this one, which you know you're going to get down and hit positive. But if this one over here that's floating just on its spring tension isn't making a good connection, then the motor isn't going to run, and you'll have to get in and adjust it. And what happens a lot, and you can see it a little bit on here, the fiberboard through the years, see how that's kind of going up? Maybe you can see that. I've seen them much, much worse, where the fiberboard has gotten moist or whatever, and through the years has curved up. Well, that takes the tension off of these, so they don't always make a good connection on the top plate because the fiberboard has warped so much. You can see it on this end. They always tend to warp more at this end because this is the end where the big bundle of wires is coming out, and that puts pressure on there too. So if you have a remote that's finicky and not always working, now you know how you can take that apart. If you need to, you can bend these up a little bit more so they have more spring tension pushing up to make sure they're making a good connection. Or if you think they're corroded, you can take them apart. Or if you have a broken wire where it enters the remote, you're gonna have to grind. You're gonna have to take these things out, swing the poles to the side like I did, and get in with a Dremel and grind that little pin off. And I set it in the cap. But let's put the cap back on. As you can see, the cap has got little ridges, and then there's ridges on the side. So when this is in place, it should snap down and give you your connections. As far as the ones that are broken, there isn't really any way to fix it. If you happen to have the broken piece that's off, this is styrene plastic, just like any model kit from that era. You can then re-glue that broken little piece back on with styrene because it actually will fuse the plastic together because it's a solvent weld. But other than that, you're kind of screwed. You can see the tape marks here. Through the years, people have held it together with tape and rubber bands and stuff like that. I think that's about all I had to say about that. In case you had to repair one of these remotes, that's how you get into it. That's what's going on inside there.